Sorry about that. Someone decided to plug in an electric heater and a vacuum cleaner at the same time, so the circuit tripped. So, as I was mentioning earlier, ports are virtual. Here is a list of about 10 to 11 ports that are used frequently, and they're used every day. One of the biggest ports on here that are used more commonly every day is port 53, DNS. So my computer here at my house is named Goliath 2, but on the network, it's not, well, on my local network, it's also called Goliath 2. But once it reaches out to Google, my router translates that through something called DNS, Domain Name Service Protocol, and it takes that name of Goliath 2 and translates it into numbers that the Google server, which could be 127.0.0.1, I just made that up, but it'll reach out to that server and say, hey, this computer, which is this string of characters / numbers, is requesting information to look up cooking recipes. And then it'll send that back and display that on my screen. Another one is port 80. That one's pretty big. When you go to any website, you're essentially traveling through hypertext transfer protocol, which is port 80, which you will load articles when you look up things, when you read things, and search for things. There's a bunch of more of them. I don't want to really get into it because they can get very, very convoluted very fast. But port 123 is pretty important because I don't know if you've ever noticed, but most of your clocks and your computers are synced online for a reason. That's to keep all networks in sync, and they all flew through this port. It's just a little tidbit of information that you might not need anytime soon, but it's one of the things to know just for a random conversation to impress people. I guess you could have it in the back of your head. So moving on to the next slide. As I stated, we were going to talk about IP and TCP. So I just stated them backwards, I know. So what is TCP/IP? TCP stands for Transmission Control Protocol. And transmission control protocol, excuse me, it specifies a computer's IP address, and it details the message to be sent to another computer in the form of a guarantee. So let's say you send the word A, and A is made up into 8 packets. If packet 2 of 8 fails, it'll resend 2, then it'll tell it to rebuild it in order. And that's essentially how TCP works. Here's the packet I was talking about. So inside each packet, as you can see, there is something where the destination MAC. So where's the hardware address where it's going? Here's the source address of where it's coming from, which would be from your machine. The destination IP, which is, let's say, 256 King Street, and it's coming from 123 King Street. And here's what's in it. This could be the letter A or what have you. And there's the closing end of it right there. And as I stated earlier, we already know what IP is now, hopefully. It's essentially an octet of numbers, so 192.168.1.165. You can think of that as your street address, as I said earlier, which would be 123 King Street. So moving on to IPv4 here. It's protocol version 4. Maybe you've heard that we're running out of something called addresses in the world. Oh, what the heck does that mean? Every website, every place you visit, every service, essentially, if you play online, connects to servers, they have an IP. We're running out of those numbers. So they've developed rather something called IPv6, which I will not get into because that is very, very complex. So an IP address, as I've stated before, is a long string of numbers made up of 4 octets. And each octet is normally described in decimals. So as I've stated, here we go, I can't draw this. There you go. 192.168.1.165. Oh, that is the weirdest looking 5 on the planet. But that's 5. That's essentially what an IP address looks like. So let me go to the next slide. There you go. See? Well, or clear to see. This right here is the IP address that will be assigned to a machine that can be sent out. And there's something else called a subnet mask. That's something I really haven't mentioned until now. Essentially, what a subnet mask is it's used in conjunction with the IP address to divide it. where it lives on your network. So, subnet mask for your computer would be 252.5.25.0. Then everything else on your network would have that same subnet mask. So anything, like the Roku on your network would know, hey, I can talk to this computer as long as it's within subnet mask 255.255.250. That's the things that communicate. Like the printer would have the same subnet mask, et cetera, et cetera. But let's say your computer wants to request something from Google. It will check, hey, can I reach Google in this subnet mask now? Okay, let me go outside and let me go talk to the router that's also on here that's a subnet mask. With this router, which has what's called a default gateway, which I have listed there. That's a specifically designed reserved port. The router can reach out to Google, which Google's IP address would be what have you 127.0.0.1, and tell it, hey, computer, whatever name is converted into these numbers, as I stated earlier, is requesting information. Can you please send it, coloring books? And it would go from there. So moving on, we're going to be covering network topologies. These are, 4 of them. They're not too in-depth or too elaborate, but they do get used every now and then. So the first two I'm going to introduce you to are bus and star topology. As you can see here on the screen, the bus is just one straight line with a bunch of computers connected to it. That's probably one of the earliest and simplest forms of topologies. It's generally used most like in network cafes. You can still find them in this day and age. One of the cons is, though, being that it's one big cable. If that cable gets cut anywhere in the middle, somewhere in the end, let's say you cut it here. Let's see if we can drop there. This mouse is being weird today, sorry. You cut it there, well, now the computer is going to the right, these 3 over here. Can't talk to these 2 computers. So let's say if it was cut here, though, none of these computers can talk to anyone over here or the outside. They can still talk between each other, but if that was the only line for network communication, then they're essentially dead in the water. Moving on, there's something called star. These are not bad, but you don't see them that often anymore either. Used to take place a lot more in the early 90s. You would see them in offices, which was nice because you can have everything connected together into one area, one major production center of, let's say, copiers and one computer that is connected to the internet. It all punch into something called plug into something called a hub that you have here in the middle. The only downside to that would be is if the hub died, your network hub is dead, they're all dead in the water. If this guy goes down, forget it. That's the end. They are not talking to each other anymore at that point. They're done. You got to replace it and you got to get configured. Moving on, this one's called a ring. The ring is pretty straightforward. Excuse me. Each device is connected to each other, side by side, essentially, on either side, I'm sorry. And it's can get pretty big. Usually it's about after 7 items, you have to use something that's called a repeater, where it's a specific piece of hardware that you plug network in. And it sends the signal out and amplifies it, and then you plug that into something else, and you keep the chain going. After the other 7 devices, you add another repeater, and so on and so forth. They're pretty cost effective. They can be expensive to install, but when it comes to scalability, usually after about 14 machines, you kind of start to question yourself, because the more you add, you got to take it all down to essentially redo part of it, add it, then extend it to wherever it has to go to, add it, make sure it talks to everything, and then you go on from there. All right, and the last topography I'm going to talk about for this unit is called a mesh topography, and it's a lot of interconnectivity. Each connection each node rather, which would be each item on the network, requires its own cable and configuration once it's deployed, and it's pretty labor intensive. You see these mostly in labs. Like, what does all these topologies have to do with server? They can all be applied to a server rather. So your server can be anywhere in here and can still reach anywhere else it has to go. That's the whole point of learning all of these things. That's all. There might be in the midterm, might not. I really don't feel they're too important to remember. I might ask you about 2 of them, and I just want your opinion on. So that's all I have for you today. The next unit should be up shortly, and it's going to be talking about the servers, how we set them up, how we configure them, and how we go from there. All right. I will catch you all later.